Hi, my name is Zarata Azila binti Mohammed Zaid, and I will be talking about the introduction and theory behind this experiment. These are the components that will be discussed throughout the study: abstract, objectives, introduction, theory, apparatus and material, procedure, results and sample calculation, discussion, conclusion, and references. This experiment is based on the design of mud formulation with artificial barite using waste materials such as bentonite and water. It is mainly to determine the mud density using different concentrations of barite and artificial barite. There are two objectives in this experiment and both has been achieved. Water-based mud has been used in this entire experiment and cornstarch is the artificial barite being used. This experiment consists of two parts in which part A is the mud formulation of water-based mud using water, bentonite and barite, while part B is the mud density determination using various concentrations of barite and artificial barite. Eventually, based on results obtained and discussion, adding more cornstarch seems to replace the actual barite effectively. There are two objectives in this experiment. The first objective is to design mud formulation with artificial barite using waste materials such as bentonite and water. The second objective is to determine the mud density using different concentrations of barite and artificial barite. To understand better about the drilling mud and its effect on the drilling operation, it is actually a drilling fluid added to the oil well bore to expedite the drilling processes such as suspending, rock cuttings, and control the well pressure. Drilling mud also contains bentonite, which is the clay and barite, and useful in providing the mud weight and density. As for bentonite, it will supply enough viscosity to carry cuttings up, while barite, which is the additive, will increase the fluid density. For information, mud will contribute 5 to 15% of drilling cost, but may be the 100% factor to cause drilling problems. The effect of viscosity is that too low viscosity cause settling of cutting at bottom of well, while too high viscosity will cause a high resistance that affect the lifting performance. For density, too high drilling fluid density will lead to the loss of circulation that will then cause the break of formation. In choosing suitable material for weighing agent in mud, several factors and criteria must be considered. Barite is one of the weighing agents that meet the requirements of the American Petroleum Institute API and the International Organization for Standardization ISO. Based on Algebari in 2003, weighing agents are chosen based on factors such as cost, removal procedure, compatibility with other drilling fluid components, and drilling formation type. The minimum requirement for the density of barite is 4.20 gram per mil as stated in Table 2 in Section 7.1.2 of API specification in 2010. Today's specific gravity of barite is at 4.2 to 4.3. Due to its abundance in comparison to other weighing materials, relatively high specific gravity, low cost, relatively high solubility percentage when using chelating agents, low filtration volume and low rheological properties, transporting effectiveness and other factors, barite is frequently used. The reason why corn flour has been used is to increase the plastic viscosity of mixture in which the corn flour demonstrate the non-Newtonian fluid properties when mixed with water.
Hi, I'm Farisha Zlaika. So the first apparatus that we used was the 500 milliliter measuring jug. We used it for measuring water, and then the mixtures of mud was mixed using spindle drilling mixer. This is part of the mixer, which is its removable cup. All of the powder products materials was put out using spatula. All of the materials were weighed using O'Haver's Pioneer Balance. And for the materials that in powder form, we use weighing dish to help the process of weighing the materials. And the mud balance that we used was of 5 pressurized fluid density scale. Okay, the material that we used was 350 milliliter of water, followed by actual bentonite, actual barite, and cornstarch as artificial barite. This experiment consisted of two main procedures, which is the mud formulation of water-based mud using water, bentonite and barite, followed with the mud density determination using various concentrations of barite and artificial barite process. These two main processes can be summarized into one. So firstly, we measured 350 milliliter of water using measuring jug and pour it into a removable cup. And then the mass of bentonite and actual barite was measured and weighed using an electronic scale. 7 gram of bentonite and 36.69 gram of actual barite were then poured into the removable cup that consisted water. So the mixture was then mixed using the spindle mixer with the maximum speed until it completely mixed. When it is completely mixed, the cup was removed and poured into the mud balance cup until it overflowed. So the mud balance rider need to be adjusted until the bumper is at the center between the two indicator lines. So through then, the density of the mud can be observed and be tabulated. We can calculate the amount of barite need to achieve 9 ppg of mud. So the amount that we achieved and the amount that we estimated through calculation was compared. So step 1 still until step 9 will be repeated by using different concentrations, which is an increment of 0.5 ppg from 9.5 ppg until we reach 11 ppg. Once step 1 until 10 is completed, repeat the same procedure but use artificial barite instead. Firstly, we need to minimize the materials in the laboratory work area to avoid safety hazard. Keep your body posture correct to avoid ergonomic hazard due to repetitive actions at the counter, and make sure to do proper housekeeping frequently to avoid safety and chemical hazard. Make sure to keep your hands dry when you switch on off the switch, and also only do the experiment once it's approved by the laboratory. Do follow all of the SOPs once operating a machine, and make sure to reduce work-related hazards and switch off the main switch before you remove the removable cup. Clean the spill immediately to avoid safety hazards such as fall and
So hi, my name is Aida Sharif Suhaimi, and I'm going to proceed with the result and sample of calculations. In this experiment for the pilot testing, we used a constant of 350 ml volume of water to obtain 1 bbl of drilling mud with a mud weight of 9, 9.5, 10, 10.5 and 11 ppg. The actual mud weight obtained was measured by the use of the mud balance. In this experiment, we used a constant of 7 gram of bentonite mass. There are two methods used to calculate the mass of barite, which is by using equation 1 and equation 2. The estimation mass of barite is the mass estimated by using equation 2. For equation 2, for the 9 to 9.5 ppg, the difference of mass barite calculated is 29.47 gram. This indicates the increment of mud weight from 9 to 9.5 ppg. Using equation 2, the increment for 1 ppg of mud weight, which is from 9 to 10 ppg, can be calculated, and as calculated by the addition with the first mass of barite used, the estimation mass obtained for 10 ppg was 95.63 gram. This method is direct addition of the difference between the first and the second mass of barite used. The measured mass is the actual mass weighed in the laboratory, and it can be obtained by the use of equation 1. W1 represents the density of mixture of water and bentonite measured using the mud balance, which is 8.35 ppg, whereas the W2 is the desired mud weight. It can be observed that the measured mass of barite is greater than the estimated mass of barite in achieving the desired mud weight. Hence, it can be observed that as measured mass was used in the laboratory, the actual mud weight obtained was near to the desired mud weight. And as the barite is used as weighting agent that function to increase the mud weight of the mud, it can be stated that the method of calculation using equation 2 is not reliable, as less barite mass used will result in less mud weight obtained. Next is the data for the artificial barite. In this laboratory, we want to compare the actual mud weight obtained when actual or artificial barite was used. Therefore, to evaluate the comparison, we use the same mass for both artificial and actual barite. Thus, the calculation used was the same as the actual barite mass. Percentage error of the mud weight and mass can be obtained by using equation 3. It can be observed that the percentage error of the actual barite decreases, whereas for the artificial barite, the percentage error increases. Since the percentage error of the mud weight when artificial barite was used is greater, it indicates that more mass of artificial barite must be added to obtain the desired mud weight. Since mass of both were kept the same, the percentage error of mass of actual and artificial barite was the same, and the trend increases with the increase of the mud weight. This indicates that the mass used should be increased more to lessen the percentage error obtained. From the table, it can be observed that for artificial barite, the actual mud weight was far from the desired mud weight compared to when actual barite was used. Hence, the percentage differences were calculated as both did not achieve the desired mud weight. And to compare these two values determined by the experimentation, the difference of the two values were observed as their percentage of their average value. The percentage differences between mud weight observed when actual and artificial barite used can be calculated using equation 4. And based on the table, increased percentage differences were observed with the increase of the mud weight desired.
So next is the discussion. So the objective of this experiment is to create a mud formulation with artificial barite using one type of waste, bentonite and water, and to determine mud density using different concentration of barite and artificial barite density. So this experiment consists of two parts. For the first part includes the mud formulation of the water-based mud with bentonite and barite as the weighting agent. The formulation of mud was prepared by mixing the water, bentonite and barite using the mixer, and then the measure bentonite and water were observed, which is to be 8.35 ppg. This value was used in the calculation of theoretical for the determination and artificial barite. So as you can see, based on the graph, mass actual and artificial barite is greater than the theoretical barite, but the density is lower than theoretical. 8.7 ppg of mud density can be obtained by the utilization of actual barite, which is close to the value of estimated barite. However, only 8.5 ppg of the mud weight was obtained when artificial barite is utilized, even when the same mass is used. So the graph shows that the density of mud increase as the mass of barite increase. In general, barite addition raises the mud filtration by bridging the filter paper and the rock formation. Hence, it also enhances mud density, mud cake thickness, and mud viscosity. Barite is a typical wetting chemical used in drilling fluids to generate high density fluids capable of drilling deep oil and gas wells. When the density of the drilling fluid is increased, the characteristic of the drilling fluid change noticeably. Its major property is that it is 4 times heavier than water thanks to its density of 4.2 specific gravity, which is equivalent to 4.2 metric tons per meter per m3. Barite helps regulate and maintain the hydrostatic pressure in the well by acting as a wetting agent, which is minimize the blowout. As you can see in the table, that is the mud formulation suggested by Fatah and Lashin in 2016, and it can be observed that 9 ppg of mud weight can be achieved by using the mud formulation suggested by the study. So compared the mud formulation suggested in this experiment, there were significant difference, and this indicates that the amount of bentonite and barite should be increased more to obtain to desired mud weight. A constant value of actual and artificial barite was added for the mud formulation, and this was done for easy analysis of the effectiveness of artificial barite to replace the actual barite. Hence, it can be observed that the percentage error of mud weight with the artificial barite was in the range of 5.88 to 18.28%, whereas 3.45 to 2.80 percentage error of the mud weight was observed when the actual barite was used. The percentage difference between B and C you can see from the table 7.4, the table before. So you can see there is an increased trend, and it is in range of 2 to 40%, which is an optimum level of percentage difference. So to decrease the percentage error of mud weight with artificial barite, certain adjustment must be done. So which the mass of barite added into the formulation must be increased to an adequate level. So cornstarch can be utilized in the oil and gas industry as the wetting agent and additive in mud formulation to prevent fluid loss in the formation. Fluid loss can lead to problems such as stuck pipes and formation damage. This use of corn starch can prevent fluid loss in the formation due to its ability to form as a colloid particle. The particles can bend or compress to cover the pores in the filter cake, which help lower the likelihood of fluid loss. Hence, due to its low bottom hole temperature, high biodegradability, lack of environmental impact, ready availability, and inexpensive cost, cornstarch can be used in place of barite as an effective wetting agent. So for the conclusion, in conclusion, this experiment objective were met. The experiment primary goal was to create a mud composition containing artificial barite, utilizing bentonite, water, and one kind of waste material. Hence, cornstarch was used as a artificial barite in this experiment. So the second goal is determine mud density using varied amount of barite and artificial barite was also accomplished. The graph trend shows a rise in the value of actual and artificial barite mass as the mud weight density increase. It can also be seen that a greater quantity of the corn starch, which is the artificial barite, was required to obtain the same mud weight density as the barite was created. This indicates that by adding more amount of cornstarch to an adequate level, it can effectively replace the actual barite as the weighting agent in mud formulation, and percentage error can be reduced to an optimum level.